So we'd like to ask you to introduce yourselves, and then we'll get on with the competition.
My name is Wilton Wu.
My name is Alan Zhang.
My name is Anant Karkar.
My name is Will Overman.
My name is Pranay Vissa. We're seniors, and he's a junior at Maggie Governor's School in Richmond, Virginia. And our coach is Mr. Dixon Benish, wherever he is in the back.
Okay.
Right, you may begin.
Good morning, everyone. We are team 4892 from Maggie L. Walker Governor's School in Richmond, Virginia, and this is our model for the 2015 Moody's Mega Math Challenge. Our task this year was to determine the cost, return, and value of a college education. Our first model estimates the cost of a college degree. Our second model utilizes an iterative function to calculate the earning potential of a STEM versus non-STEM major. And our third model combines our first two models along with a personalized survey to determine the overall happiness of certain career choices. Now I will be handing it over to Alan Zhang, who will explain the details of our first model.
Thank you. So the first part of our challenge was to estimate the cost of attending college for different types of families. And in order to do that, we just asked a magic 8-ball. No, we actually didn't. If only it were for that easy. Instead, we used the federal free application for federal student aid, otherwise known as the FAFSA. We accommodated for families, two different types of families, one with one parent and one child, and the other with two parents and three children, each earning incomes of $35,000, $75,000, and $125,000 a year. We chose the FAFSA because it is the document that many colleges use to determine a student's final cost of attending college. And in addition, using the FAFSA simplified worksheet only requires using a few extra assumptions, which are as follows. We assume that the student and family lived in Virginia to establish a platform for consistency, which is then used in later platform models. We also assume that parents maintain their current level of income, that students do not work at college, that parents send one child to college at a time, and perhaps most importantly, that students receive no further scholarships, because in many cases, additional aid is used to first pay back the government instead of the student. By calculating the various allowances the government provides and subtracting it from total income, available adjusted income could be calculated, the value of which could be placed in one of FAFSA's tables to determine EFC, or expected family contribution, the values of which can be seen in this table right here. At this point, finding the total cost is simply a matter of obtaining the financial aid information from the college's website and multiplying the college's sticker price above the EFC by the percentage of unmet financial need, which is represented in the formula below. Many schools advertise that they meet 100% of financially demonstrated need, in which case the final cost is just equal to the EFC, like in the table above. Some notable findings include the fact that as income increases, the expected family contribution increases. As family size increases, the expected family contribution decreases. In fact, for a family size of three children and two parents earning $35,000 a year, the expected family contribution is actually $0. In addition, as income increases, the rate at which the EFC increases rises as well. To improve our model for the future, we could take into account work-study grants, which could help offset the cost of college for the student. In addition of using a constant in the EFC formula, we could also account for various families sending multiple children to college at the same time. Lastly, we could also survey recent college graduates in order to calibrate our model, which might help account for factors such as personal trips to home or transportation costs. At this time, I'll hand it over to Anand, who will explain the second part of our model.
Thank you, Alan. So I will be presenting the second part of the problem, which asked us to evaluate the returns on 4 different college paths, which are directly entering the workforce after high school. Second is attending a 2-year community college and receiving an associate's degree after high school. The third is to go to a 4-year university and receiving a non-STEM related bachelor's degree. And fourth and finally, attending a similar 4-year university and receiving a STEM degree. And our approach to this problem was to determine essentially the net worth of the average individual in each of these 4 college paths. Now, in our case, the net worth variable that we're going to refer to did not actually include assets, and so you'll see in our graphs later on that we actually refer to it as money in the bank, because it's really more a matter of disposable income or more of a matter of savings and debt. And so there are a few key assumptions that we had to have for this model. The first is that the cost of living of an individual during their time in college is included in the final cost that Alan just presented. Second, the cost of living of an individual in the workforce is based on data for Richmond, Virginia. Now that's our hometown, which is why we use those numbers. But more importantly, that variable can be interchanged for any individual anywhere in the world based on the city and the location that that individual is working in. And so we used Richmond, Virginia as a demonstrative example, but it can be changed to better fit any individual in the world based on his or her own personal situation. Third, and this is a very important one, is that all disposable income earned by an individual goes directly towards paying off college loans or college debt. And while that doesn't always happen in reality, in our case it was effective for comparing the different college paths. And fourth and finally is that the unemployment rates within each of these fields remains constant over time. So the model itself begins with this equation that you can see on the slide, which demonstrates how to calculate our net worth for an individual in a certain year Y during their time in college. And that's essentially determined by the annual cost of attending college that year added to the net worth from the previous year. And since the student is in college, that net worth is negative, representing debt. Once the student graduates from college, if they choose to attend college, there will be a period of time for which the student is in debt because of those college payments. And so the net worth for that individual during this period of time is determined by their income minus their cost of living, which is just based on their location, as stated before, added to their net worth from the previous year. And since that net worth is negative because of debt, there's an interest that's accrued on that net worth. Now, it's important to note that in our case, income was not simply the amount of money that a certain individual made. It was a derived metric because we wanted to account for job stability. So we multiplied the median salary for any particular degree or career field by the employment rate for that career field to penalize career paths that didn't have the same job stability as others did. And finally, once an individual graduates, once an individual has completely paid off that college loan and no longer has college debt, the equation changes slightly in that the net worth from the previous year, W sub y minus 1, becomes 0 or positive, and therefore there's no interest accrued on it because there is no debt. And now I'm going to hand it over to Will, who's going to be discussing the findings of this model and some of our results.
In order to actually use this model, we had to find data for it. To do that, we did some research online and found actually a nice resource from Nate Silver, the famous analyst website, where he had compared different majors. And we were actually able to take his statistics for the different majors and sort them in the STEM and non-STEM and find the incomes for those and put it into our income metric that Anant explained earlier. And from doing that, we can see the graphs here. The red one represents the STEM graduates, the yellow is the associates, and the gray is the non-STEM 4-year graduates. Important parts that we can see from this graph is that after 20 years, the STEM graduate is far out earning or has more money in the bank than all the other options. But the most notable result, in our opinion, was that the associates, the person who went to community college and obtained an associate's degree, actually was outperforming those who went to a 4-year college and got a non-STEM degree. And we could actually see this to also be true in this next family situation where you have a different situation, 2 parents, 3 children with a much higher income. So even for this different situation, we can find that the non-STEM person who went to 4-year normal college was actually making less than those who went to community college. We were actually able to find data that supported, or like newspaper articles online that supported this claim and found that this was actually a trend people were starting to notice. So we were very encouraged by that. And finally, we were asked to talk about Obama's plan of offering free community college. Yellow represents what it would be without his program, and purple is what it would be with. Sadly, we can find that there are actually very similar results in the long term. You can only see a slight difference in the first 1 or 2 years, where the person who had to pay for it on their own just takes that like $2,000 average hit that it would cost to go to community college. Even though there isn't much of a difference in the long run, we could see that his program would definitely be a catalyst to encourage students to pursue an associate's degree, which, as we could see from the previous models where it was outperforming a non-STEM degree, would be a very good thing for them to possibly pursue. And finally, some improvements for this part of the model would be to write a program that can give a personalized or individualized graphs depending on your situation. So instead of just looking at the six familial situations that we were given, we could account for any different one. And also, you would be able to change the cost of living constants that we assumed like were for Richmond. We could put it in for any different area, and we could, based on the program, give you your own graph showing you how the different options pair up for you. And also, we would want to account for job stability across each field, because logically it would make sense that someone who's an engineer or works in the medical field is going to have their job even if there's a recession, while someone in a non-STEM field may suffer more from a recession. So finally, I'm going to turn it over to Pranay to explain the third model.
Thank you, Will. So thus far in our methodology, we've tried to determine the cost of these 4 different career paths. But I mean, cost is one thing, but who really cares? At the end of the day, when you're a senior in high school, do you really care? Is the only factor how much you're going to earn after 20 or 30 years, or whether you're really going to be happy in that job? And that's a question many people consider throughout their lifetime. And so to determine whether students will be happy, or how to determine whether the 4 different career paths give different levels of happiness, we tried to create a double survey model. And we did this in 2 ways. The first survey was sent out. We didn't actually send out the survey in our 14 hours, but the survey would be sent out to employees across all over the country, and they would tell us what they pursued, whether it was a 4-year STEM degree, a non-STEM degree, an associate's degree, or they went directly into the workforce. And we will compile a database of information from them. Subsequently, we will also survey students or seniors in high school for them to use the data from the employees to see if maybe an associate's is the right path for you, or maybe a 4-year STEM degree is the right path for you. And so the way we did this was we asked a few simple questions. The first one for employees is, what is your level of education? And that's how we stratify our data. And the 3 variables that we focused on was the amount of time the employee spends with their family, because that's something that many people do consider when considering a job. And second, how satisfied they are with their career after 10, 20, or 30 years. And then we also asked how stressful your career is. These are just 3 parameters that we determined, but any survey can really interchange that with any other variables that they deem as important for job satisfaction. And we asked, if you notice, we asked high school students a very similar question in questions 4, 5, and 6. But questions 1, 2, and 3 are really the crux of this model, in that if you look at our second model, we have graphs based on income and family situation. And so we have a different economic outcome for each student in a different family situation and different economic background. And based on the first and second question, that is their parental income and whether they're willing to invest in a short-term, or whether they're willing to invest in long-term education, or they immediately need money, we can determine which graph that we apply to them in that situation. And the third question is very straightforward. If you're interested in STEM, you're probably better off pursuing a STEM career. It's important to understand a few variables for this model. The first variable is this idea of a net worth ratio. The net worth ratio is based off of the average net worth for all employees of a given career field, divided by the maximum possible net worth across the career fields. For example, if 10,000 people who had an associate's degree on average reported that their net worth was $80,000, whereas the highest earning group was STEM graduates with $100,000, the net worth ratio would be 0.8, 80,000 divided by 100,000. And we used a similar methodology for work-life balance, job satisfaction, and stress. And so finally, to bring this all together in this nifty flowchart, we looked at, like I mentioned before, from the employee survey in their education level, and we crossed it with the student survey of what their income was, how quickly they wanted an income, and whether they were interested in STEM degree. And we used a similar methodology for our next three, for family time spent, how satisfied they are with their career, and if they're stressed or not. And this is simply a mathematical representation of our formula. In the individual survey, there is a 1 out of 10 scale for stress, work satisfaction, and family life. For example, if a student says that job satisfaction is a 6 out of 10 for them, we will give them a 0.6 weighting for that variable. Therefore, if they are interested, if that's what interests them, then it'll be more important for their model. A few improvements are that all ratios are not created equally. That means that giving up a tenth of job satisfaction may not be the same as giving up 1/10 of stress. Students have not already browsed monster.com. What that means is not every student knows whether, I want to go work for Moody's one day. And how is an 18-year-old supposed to think about work-life balance? That's something that we could improve our survey by sort of drawing out the conclusion rather than asking them directly. And so based on our conclusions, we're not advocating that everyone go and automatically pursue a STEM degree. The CEO of the Moody's Corporation is a political science major, and I'm sure he's happy with his career right now. But, numbers sometimes don't lie, and so if that's really what you want to do, then the STEM career is the best option for you. Thank you. We'll take some questions.
All right.
Dr. Paluzzo.
Thank you. Yes, and thank you for your presentation. So I'd like to get started by asking you about something that's early in your presentation, in particular your discussion of need you had for students. First, it's sort of a two-parter, but I was wondering how much information you were able to find out about how much schools are able to offer in terms of providing need for students who demonstrate they have need. And then how would variability in those numbers affect your model?
Right. So we determined, at least from our local area, that a lot of schools say that they actually do meet 100% of demonstrated financial need. So that's kind of set our baseline for what we could expect to find in our graphs. However, looking at how unmet need would affect the outcomes after 20 or 30 years, what it basically did was it pushed down the STEM and non-STEM four-year college slopes graph. So they'd earn less after 30 years, which would actually make the associate's degree an even more preferable option in terms of earning income. But it was never the case where STEM would be pushed farther down than to be worse than the associate's degree at the 30-year term. So we could always recommend that over the course of a student's entire career, even if they had to pay the full sticker price of college. And it would also never be the case where after 30 years, the non-STEM career would be able to catch up to the associate's degree. So we are also able to always recommend that as a full career choice for those pursuing associate's degree.
I can also address this question if you would like.
Sure.
Another thing we found was that these schools like Stanford or MIT, say where they have a lot of STEM majors that come from them and do very successful, have much larger endowment than other schools. So they have more money given back to them by their alumni, which then can be put towards meeting more of the need that's demonstrated. So these STEM schools where a lot of STEM people would be going would actually see a bit of an increase compared to the non-STEM in terms of you have STEM people giving back to other STEM people is going to even raise them even higher than the other graphs.
And finally, just one final point on that question is what we found in terms of availability of the data is that a lot of colleges now are increasingly publishing or publicly providing more information about how much financial need they do meet. Some colleges also stratify that by income brackets, but it's more just a matter of colleges are providing that information more. So in our case, it would really just be a matter of, for any particular college that would be used in our model, that would be a statistic that could be obtained from any particular college.
Thank you.
With respect to the question of the potential policy change of maybe 2 years of community college for free, Did you take into account at any point the possibility that a student might participate in a program, and these currently exist, where one goes to community college for 2 years and then follows on with 3 more years at an engineering school, or any combination of doing sort of this first 2 years at a college and then following on to get the 4-year degree?
We didn't account for that specifically in our model, but our model is very versatile in that you could use the equations that we did for calculating the net worth in college and just have that be 0 for the first 2 years. So like up to worth in year 2 would be equal to 0. And then once you start going to that college, then you would start getting the tacked on the cost of those colleges. So in that way, it would adapt for it itself. And instead of running through that iteration for 4 years like you would from another program, it would just go for 3 you would see when you did that.
I think we could expect similar results from the STEM graduate who went straight into a 4-year college and the one that went into a 2-year college first. Because although you do save money on those first 2 years of college, you do miss out on a year in that case of earning potentially maybe $60,000, $70,000 of income, which would offset the extra expense you might have had to pay if you went straight into a 4-year college.
Can you bring up the chart with the 30-year sort of payback graphs? That one. Yeah, and just for example, will one of you explain what's going on with the gray curve and the orange curve, the breakpoints, the slopes, and just tell us what's going on there.
Okay, so the red and the orange?
The gray and the...
Sure.
The gray one and the red one?
Red one.
Okay.
Yeah.
So the gray one is the one for non-STEM graduates, and we can see that they both have the same values up through year 4, because you're going to be paying the same for getting either a degree at a 4-year college. And then you're going into the negative. You have a negative slope there because you're getting into debt. But once you leave that phase, once you leave college, then you're going to start making money, and they both have positive slopes. But we're going to see the reason it breaks into 2 is we actually, when we wrote the paper, we explained this better. We had our initial career phase and then a late career phase, because we assumed you wouldn't be making as much in basically any job in your first 5 years of it, because you will have a larger income later in your career. And we looked at the differences between how much of a difference that is for STEM and non-STEM. So that's the reason there's even a greater increase after that early career phase for the STEM graduates. So after that, we assume that was the first 5 years after you graduated college. So in year 9, you start to see a greater slope for both careers. And we can see at this point, the STEM graduate has already passed the non-STEM just because they were making more even in the early career phase. And after this point, it's just a rocket climb above where you would be for a non-STEM graduate.
I have 2 questions about your high school survey. So the first question is, can you discuss the pros and cons of having a scale from 1 to 10? Like you mentioned, 1/10 of your stress. How did you pick that, and would there be advantages if you were going to revise your model? Would you stick with 10, or would you have more or less on that scale?
So I can address that question. What we would do if we were taking the survey and providing it to the public is we would take the results of our very first survey, which was provided to individuals in the workforce, and we would take the results of that survey and provide them as guidelines for the second survey. So for example, if we had results coming back from that first survey that said career choice X tends to have a very high stress level, whereas career choice Y tends to have a very low stress level, we would provide those as examples for the individuals to give them a better guideline of what a 10 would be in terms of stress, or what a 1 would be in terms of stress. And that would allow us to calibrate the model more for what a 10 really means and what a 1 really means. And that would also give the student a better way to judge how much stress they really are willing to take on, as opposed to just a number from 1 to 10.
In addition,
I'm going to push you on that one. So 1 versus 10, I understand. 5 versus 6, I don't know if I understand.
right, and
So is 10? Do you need 10? Is 10 as simple as it can be?
well, I mean, that's one of the improvements we mentioned in our model. I'm personally not an advocate of such a black and white survey that asks, at the end of high school whether you're 10 for stress or job satisfaction. I think giving up a 10th of stress for some people may be more than giving up a tenth of family time spent, and for some people, the variable itself may be worth more. And so I think we really could have accounted for that, but given the limited time span of about 14 hours, we just threw in some black and white questions. But I think definitely if we could have a more expansive survey that draws out whether the student really values stress or really values job satisfaction rather than asking them directly up front, I think we could have a much stronger analysis of their personal preferences.
So like a not mentioned, in the calibration of our model, it could turn out that people who said 1 on the survey could expect maybe 10 hours of family time a day, while people who answered 10 on the survey could expect maybe only 1 to 2 hours per day. And so the difference between like a 1 or 2 and 5 or 6 could be maybe around half an hour. And if such a difference is meaningful to the student, then yes, we'd break it up into 0 and 10. But if it only turns out to be a difference of 5-10 minutes, then having such a wide scale from 1 to 10 probably wouldn't be what we'd shoot for, and we'd shoot for something smaller.
Thanks. Okay, my other question was, at some point they were supposed to say how much they wanted to be satisfied or dissatisfied with their job. And so they were choosing between, I'd like to be extremely satisfied, to I'd like to be extremely dissatisfied. So we wondered under what circumstances you might answer the question to say, I would like to be extremely dissatisfied.
I think job satisfaction perhaps is not the best way to phrase that question, but for some people, in high school, you may think, maybe I just want to make a lot of money. And there are certainly people out there for whom that's a big consideration. And so job satisfaction for me may not be a big deal. I really don't care what I do, and I don't care how, whether my boss is nice to me, whether I get along with my coworkers. But if I'm making $200,000 a year, sure, why not? And so I think those are a few circumstances where people would say, but I mean, we're obviously not advocating for such a situation.
Not a value. Again, you're getting back to your weights for values. Thanks.
Okay, thank you very much.